Hello and welcome. This is Hermann Ruckabauer with I Know How, and I'm doing a lot of memory interface verification with interposers. And therefore I have put together a small video where I'm showing how I'm going to use an interposer, how to solder the probes, how to prepare it, and how to secure it to make it sure that everything is fine for doing the measurements. Have fun with this video. So let's take a look to our DUT today. And this is a DIMM, a DDR4 DIMM in this case, and as you see the interposer is mounted here somewhere on the left. Sorry for having this kind of arrangement, but my camera did not allow me to put it more to the center, so you see also the right side of the DIMM. Otherwise I think everything is fine, and this is how your DUT should look like with an interposer assembled. Now let's fix the DUT in order that we can nicely solder on it. In this case I'm using Kapton tape. There is ESD proven Kapton tape and non-ESD proven Kapton tape. So make sure you're using the right one. Now let's start to prepare the interposer for soldering. I'm using here a probe tip with about 100 micron diameter, and also the solder wire is about 100 micron diameter. And I'm using no flux, but just because the video was not clear when there was a flux used on the interposer, I strongly recommend to use flux for soldering here. And here I'm just trying to get some solder on all of the pads that I'm going to use later on for soldering. And as you see here, I'm running a little bit in trouble because my camera always focused on the wrong thing, in this case on my nails, and I have to admit, looking to the pictures, I see I should have done my nails before I did the video, but that's how it is. So in this case, my nails are not that nice. And as you see here, we have always, in this case, a differential pair. This was a clock, and also added some ground pads for single-ended measurements. This case, this signal is command address signal, also with already two ground pads prepared, just to make sure that when I'm soldering the probe, I have enough flexibility to also solder down the ground. It really depends on your probe, which pads you're going to need. And I just know for the probes that I'm going to use later on, nearby ground here is of course the best from a signal integrity point of view, but also for the probe itself. Here we are going to do the DQS signals. So we have DQS and DQS bar, and also in order to allow single-ended measurements, I prepared already two pads with ground. So in this interposer, there is the outer pad row always completely ground. Then of course we also need a DQ. So here we are going to see the DQ line or the DQ signal to be prepared. And it seems that I should have given more wire for the solder wire, but still I did not burn my hand, so I did it right now. Now I'm coming back for additional ground pads here, because I think that it depends on the direction of the probe. So I thought it might be a good idea to have some more ground pads prepared already. A little bit heating up again to make sure that everything is nicely welded, and we have a nice solder point. And last but not least, we have the chip select here on this side, with then again a ground signal on the outer side. So basically that's what I do for preparing the interposer for measurement. Here you can see the interposer with the prepared pads. So we have clock, we have an address, we have DQS, we have a DQ line and a chip select. And on this interposer, the outer pads are all the ground pads, so we have also enough ground in order to do single-ended measurements and also to capture DQ or chip select or address single-ended. I think this is good enough now to start with soldering the probes. Now let's take a look in soldering the probes. Here you see the probe is coming up from the bottom side. Sorry for shaking this much, but I just took it far away from the end. And then I realized, oh, if I place my probe here, I'm running into trouble because I cannot fix it anymore. Because of the fixture of my DOT, the Kapton tape there. And therefore I had to remove the Kapton tape on the left side and assemble it a little bit further out left, so I'm sure that I can really nicely fix all the probes that I'm going to solder later on. But now I can start to solder or prepare the probe for soldering, and as you see here with my tweezers I try to adjust the probe, the distance between the plus and minus connections to my pads. I'm going to fix it first because before I'm going to solder the probe in here. Again, I used Kapton tape, so this is just should be just a preliminary fixture there. Readjusting it with the tweezer, holding it down a little bit to make sure that I don't have too much pressure there, and then I'm going to just touch the solder joints a little bit in order to get the traces, the wires slightly fixed. In this case I'm just cutting the Kapton tape to fix the probe to make sure that I'm nicely fixed but not really glued down to the surface there. And here you see the first probe soldered. As you see, the right contact should have been a little bit more to the right. It's difficult to see that there is no short between the two pads here, but definitely there is not. I have a little bit on solder here, but this is a don't care there. Now let's go for the second probe. In this case I'm going to solder the clock plus and clock minus. You see again I'm starting to first slightly adjust the wires, then I'm going to try to place it close to my clock. Again I'm ultrasonic soldering with a lot of shaking. But now I need to finish the placement, and also here I have my soldering iron doing it shortly here. In this case I did not first fix it. I fixed it with the first solder down, and now I have also the second one nicely soldered. And of course later on I need to start fixing it. But I was not happy with my soldering there. I really just used the first solder joint as short fixture, then I fixed it with the Kapton tape, and now I'm going to check out the second one a little bit better, adjusting it with the tweezers, and got it nicely fixed now after a new check. Let's now do the final fixing of the probe, in this case a little bit faster than usual, in order to save a little bit of time. And for a real probe fixture I might have done it slightly differently. I might have bent it to the bottom of the DIMM, and I used the leftover to isolate the left probe again a little bit in order to solder an additional probe on top of it. Now let's take a look to the close-up view of the probe on the right side, where we have clock true and clock complement. And on the left side, as you see, the solder joints and also the resistors on the probe tip are isolated by this additional Kapton tape that I put on top of it, because I would like to have another probe above it. And here finally an even more close up there to show the solder joints a little bit better with the banding of the probe tip wires and resistors of the probe. As you see here, the bottom of this probe is intended to be on the bottom side, and this is as it should be. Now let's go on for the third probe for the chip select, which is just above the clock, and I have to admit I was not happy now to solder directly on top of it, so I did the stress relief and bending that Keysight usually proposes, to have a nice bend on the probe tip there, trying to arrange it where to place it, but finally it turned out I was still not happy to solder it directly there. So I'm doing the probe tip wire adjustment, and then I grabbed for a little bit more Kapton tape, and as on the left side, I'm going to isolate the probe with the Kapton tape here. Make sure that I still can connect to the probe pads on the upper side of the Kapton tape here, using my tweezers to hold it, and then again starting to solder down on the first test point. And after having fixed this one, I'm going to try to rearrange the second probe wire. And finally solder down my ground connection of the probe on the outer pad row of the interposer. And here again, as usual, the close-up view of the soldered probe, here in this case for the chip select, and the ground on the upper right side of the picture. Now let's go on with the next probe. And as you see here, as the probe comes in, this time is a new, freshly untouched probe with quite long wires. And therefore the first thing that I have to do is to cut them off with my wire cutter. Keysight is providing two different de-embedding models for different lengths, and yeah, theoretically one can optimize the lengths here exactly to the model, but I have to admit this is something I usually do not do. But in this case I would use the shorter one. And of course in this case I also have the same length for power and ground, which for signal and ground, which is not often the case. Quite often I do have different lengths depending on the angle where I'm going to bring in the probe from top or from the side. I'm also adding a little bit of additional solder wire because my original one was not good enough to really get a nice connectivity here. And now I'm having the second or the first DQ line also wired, and again I'm going to isolate it because I need to solder the DQS on top of it. In this case again a used probe, so the wires are already a little bit shorter than usually. By the way, I'm going to reuse these probes quite often, so if you take a little bit of care, they are quite stable and are long lasting. And now, last but not least, I have to solder to fix all the probes. And here you might see that I did a mistake. I pushed down my strain relief bow, and this was not good for my probe connection, but still good enough to work on. Let's take a last look to the close-up. On the upper left you see DQS true and complement, a little bit underneath the DQ with the isolation with the Kapton tape. And on the right side you see the chip select, and you also notice that now the wires are bent backwards because of my failure and pushing down the strain relief bow, and this caused a little bit of trouble there. That's it for soldering the probes and fixing them a little bit with Kapton tape. In case the DOT is very close to the scope and the soldering station and it does not need to be moved anymore, this is good enough. If you have to move the DOT, it's recommended to fix it better by hot glue and additional or liquid solder mask. I hope you enjoyed the video and it helps you to solder your probes on the interposer, and have fun soldering. Bye bye.